Hello all, welcome to Brilliant Coaching Classes. I am Nilima Patil. Now we will see how to solve question 2 of exercise 1.1 of rational numbers. The question is, write the additive inverse of each of the following. In that, first is given 2 by 8. Now to write the additive inverse, you just change the sign and you will get additive inverse. So here 2 by 8 is given, which is positive. So we will write negative 2 by 8, and this is additive inverse of 2 by 8. Negative 2 by 8 is additive inverse of 2 by 8. Why do we say that this is additive inverse? Now if you add these two numbers, these two rational numbers, 2 by 8 plus minus 2 by 8, and the answer will be 0. So by adding these two, we will get 0, and therefore minus 2 by 8 is an additive inverse of 2 by 8. So just by changing their sign, you get additive inverse. Second, negative 5 by 9. Now here it is negative, so we will write positive. So 5 by 9. 5 by 9 is an additive inverse of negative 5 by 9. Next, negative 6 by negative 5, minus 6 by minus 5. Now you know that minus 6 by minus 5, this minus minus sign will get cancelled, or you can say minus minus will become plus, and so this minus 6 by minus 5 is equal to 6 by 5. And now we will write the additive inverse of this. Now this is positive, so the additive inverse of 6 by 5 is negative 6 by 5. Therefore, negative 6 by 5 is an additive inverse of negative 6 by negative 5. Next, 2 by minus 9. Now, this minus sign is given in the denominator. You can write it in the numerator also, or in the center also. So, if you shift this sign, it will become minus 2 by 9. And the additive inverse will be, now this is negative, so additive inverse will be positive. So 2 by 9 is the additive inverse of 2 by minus 9. Next, 19 by minus 6. So here also we can write the negative sign in the numerator or at the center. So minus 19 by 6, and the additive inverse of this negative rational number will be positive 19 by 6. So 19 by 6 is the additive inverse of 19 by minus 6. Now we will solve question number 3. Verify that minus x is equal to x for first x is equal to 11 by 15 and second x is equal to minus 13 by 17. So for these two values separately, we have to show minus x is equal to x. So here we will consider this part as LHS and this as RHS. So left hand side and right hand side will show it equal to each other, and then it will get verified. So first left hand side LHS is equal to minus x, and just put the value of x, which is 11 by 15 here. So minus for this x we will write 11 by 15, and minus minus becomes plus, so positive 11 by 15. Now RHS, right hand side, which is given x, so again put the value of x, which is 11 by 15. Now if you observe, LHS answer is 11 by 15, RHS is also 11 by 15, and therefore LHS is equal to RHS, and therefore minus x is equal to x is verified for this value, x is equal to 11 by 15. Now for the second value, x is equal to minus 13 by 17, again we will verify this. So LHS left hand side is minus x, again just put the value of x here. So minus, again minus, and this x value is minus 13 by 17. So now there are 3 minus signs. Now see, minus minus plus and plus minus minus. So minus 13 by 17 is the left hand side part's answer. Now RHS, right hand side, is x. So put the value of x, which is minus 13 by 17. Again see, LHS answer and RHS is same. Therefore LHS is equal to RHS, and therefore minus minus x is equal to x is verified. Okay. Next, we'll solve question number 4. Find the multiplicative inverse of the following. First, minus 13. Now, what is multiplicative inverse? When you multiply two rational numbers and the product is 1, then those two rational numbers are called multiplicative inverse of each other. Now, what should we multiply to minus 13 to get answer 1, to get the product 1? See, negative 13 minus 13, we can write it minus 13 by 1. If you multiply it by minus 1 by 13, then the product will be 1, because this 13 will get cancelled, and minus minus it will be plus, you will get answer 1. So it means whenever you want to write multiplicative inverse, just change the places of numerator and denominator, change the digits, interchange their places. So 13 which is in the numerator, you will write in the denominator, and the number which is in the denominator you will write in the numerator, and the sign will be as it is. Here remember, don't change the sign for multiplicative inverse. In additive inverse we change the sign, but not here. So negative 13's multiplicative inverse is minus 1 by 13. Now this negative sign you can keep with the 13 here down in the denominator, or write it in the center, it is one and same. So I wrote minus 1 by 13. We changed the numerator and denominator digits, we interchanged it. Next, negative 13 by 19. So here again the sign will be same, but the places of numerator and denominator will be changed. So 19 will go in the numerator and 13 will come in the denominator. So minus 19 by 13 is the multiplicative inverse of minus 13 by 19. Next, 1 by 5. So multiplicative inverse of 1 by 5 is 5 by 1. 5 by 1, so that is equal to 5 only. So you can write 5 or 5 by 1, both answers are same. Now here first you find the answer, first multiply these two rational numbers, find their product, and then we'll write the multiplicative inverse. So minus minus will become plus, 5 3s are 15 and 8 7s are 56. And now we'll write the multiplicative inverse. So multiplicative inverse of this is 56 by 15. Multiplicative inverse, it means it is a reciprocal only. We can say the reciprocal also for multiplicative inverse. Now minus 1 multiplied by minus 2 by 5. So here also first we'll find the product. So minus minus plus 1 into 2 by 5 is 2 by 5. And then we'll write the multiplicative inverse. So just change the places of numerator and denominator, write 5 by 2. So this is the multiplicative inverse. Next, minus 1. Minus 1, we can write this minus 1 as minus 1 by 1. So the multiplicative inverse will be 1 by minus 1. And the minus 1 which is in the denominator, we can write in the center also. So it will be minus 1 by 1. And what is minus 1 by 1? It is same only minus 1. So the multiplicative inverse of minus 1 is minus 1 only. Okay? The reciprocal of minus 1 is minus 1. So you can write this also. Next we will solve question number 5. Name the property under multiplication used in each of the following. So which property of multiplication is used in these 3 questions? We have to write that. See, first, minus 4 by 5 multiplied by 1 is equal to 1 multiplied by minus 4 by 5 is equal to minus 4 by 5. So if you observe here, the places of rational numbers are just interchanged. So here minus 4 by 5 was written first and then into 1, but here 1 is written first and then into minus 4 by 5. So where do we interchange the numbers, in which property? And even after interchanging those numbers, we get the same product, we get the same answer. So that property is commutative property. After interchanging their numbers also, there is no effect on the product. So that is commutative property. So first, commutative property is used, and also one more property is used here. If you observe, minus 4 by 5 multiplied by 1 and 1 multiplied by minus 4 by 5, it means when these two rational numbers are multiplied in any order, and even then the answer is same. The answer is same rational number. The product is same rational number. So here closure property is also used. Closure property. Closure property. So here two properties are used, commutative property and closure property. Now second, minus 13 by 17 into minus 2 by 7 is equal to minus 2 by 7 into minus 13 by 17. So it is like this part. The numbers places are interchanged. First here minus 13 by 17, which is written here at the second place. Here at the second place minus 2 by 7, which is written at the first place. So this is commutative property. Commutative property. Now third, minus 19 by 29 multiplied by 29 by minus 19 is equal to 1. Now here the product is 1. The product of these two rational numbers is 1. When do we get the product 1? When they are reciprocals of each other, when they are multiplicative inverse of each other. So here the property used is multiplicative inverse. Multiplicative inverse.